morning, ma'am. Myself, Sushant Mawar, roll number 43 of BTech CSE 4th semester. Today, I am going to give a presentation on topic ROM that stand for Read Only Memory. So, now let's start. First, we will discuss what is ROM and how it is differentiated from RAM. Read-only memory (ROM) is primary memory unit of any computer system along with random access memory. In ROM, the binary information is stored permanently. Once it is stored, it remains within the unit even when power is turned off and on again. The information is appended in ROM in form of bits by the process known as programming the ROM. Here, programming is used to refer to hardware procedure which specifies the bits that are going to be inserted in the hardware configuration of the device. That is why ROM is also called programmable logic devices. Now let us understand what is programmable logic devices. Programmable logic devices (PLD) is an integrated circuit with internal logic gates connected through electronic paths that behave similar to fuses. In the original state, all fuses are inactive, but when we program these devices, we blow away certain fuses along with the path that must be removed to achieve particular configuration. Same happens in ROM. ROM consists of nothing but basic logic gates arranged in such a way that they store the specified bits. Typically, a PLD can have hundreds to millions of gates interconnected through hundreds to thousands of interval paths. In order to show internal logic diagram of such a device, especially symbology is used as shown in next slide. So, here we can see that the first image, that is this, is conventional way of representing inputs to a logic gate, and the second image, that is this, is a special way of showing input to a logic gate called as array logic symbol, whereas each vertical line, we can see that these are each vertical lines represent inputs to logic gate. Now moving on next slide. Now we will discuss what is the structure of ROM. So here we can see that the block diagram. In block diagram there are k number of inputs and the size of ROM is 2 raised to power k into n and the outputs are n. So first we will understand the block structure. It consists of k input lines and n output lines. The k input lines is used to take the input address from where we want to access the content of ROM. Since each of k input lines can be either 0 or 1, so there are total 2 addresses which can be referred to by these input lines, and each of these addresses contain n bit information which is given out as the output of the ROM. Such a ROM is specified as 2 raised to power k cross n ROM. 2 raised to power cross n is specified as size of the ROM. Now we will discuss about the internal structure of ROM. The internal structure of ROM consists of two basic components. First, decoder, and second, OR gates. First we will discuss what is a decoder. A decoder is a combinational circuit which is used to decode any encoded form to more such as decimal form. Basically, a decoder converts a binary number into a decimal number. So in ROM, the input to a decoder will be a binary form and the output will be represent its decimal equivalent. The decoder represented as I cross 2 raised to power L, that is I is number of input and 2 raised to power L is represented as output. It decodes into one of the 2 raised to power L decimal number. Suppose we have output of 4, so 2 raised to power 2 is represented as output. All the OR gates present in ROM will have output of decoder as their input. Now we will understand the programming of read-only memory with an example. So our example is this. Consider a 4x4 ROM, which means that it has total number of 4 addresses at which each information is stored, and each of those addresses has 4 bit information which is permanent and must be given as output when we access a particular address. So we will proceed to solution step by step. Our first step is construct a truth table which would decide the content of each address of ROM and based upon which a particular ROM will be programmed. So input goes like this. There are two inputs X and Y and there are four outputs A, B, C, D. So first we will input 0, 0 and our output will be 0, 0, 1, 1. Second we will input 0, 1 and our output will be 1, 1, 0, 0. Third we will input 1, 0 as X and Y and our output correspond to A, B, C, D will be 1, 1, 1, 1. Now at last our input to X and Y will be 1, 1 and our outputs will be 0, 1, 1, 1. Now proceed to further solution. Our step number 2. For a 2 raised to power k cross n ROM, for a 4 cross 4 ROM, the decoder to be used as 2 cross 4 decoder. So here we can see that A and B represent number of inputs, that is 2, and D0, D1, D2, D3 is represent number of output. That makes 2 cross 4 decoder. 2 here 2 represent number of input and 4 represent the output lines. So the truth table for 2 cross 4 decoder is as follows. Here we have two inputs AB and output as D0, D1, D2, D3. So for 0, 0 as A and B, we have output 1, 0, 0, 0. For 0, 1, we have 0, 1, 0, 0 as output. For input 1, 0, we have 0, 0, 1, 0 as output. For input 1, 1 correspond to AB, we have 0, 0, 0, 1 as our output for D0, D1, D2, D3. Now move further. Our last step, that is step 3, is that we have to program the intersection between the two lines as per the truth table so that the output of ROM or gates is accordance with the truth table. So to program a ROM, just look at the truth table, specify the ROM. So first we will look at the truth table of ROM. That is this. So as we can see that for A there are 2 number of 1s, for B there are 3 numbers of 1, for C there are 3 numbers of 1, for D there are 3 numbers of 1. Remember that a cross sign is used to denote the connection is left intact, and if there is no cross sign, that means there is no connection. So we will mark them. For A we have D1, D2. For B we have D1, D2, D3. For C we have D0, D2, D3. And for D we have D0, D2, D3. Now we construct circuit diagram. Here A and B represent the input lines and 2 cross 4 is our decoder. D0, D1, D2 and D3 are our outputs. So as we earlier discussed, for A we have 2 ones and it is for D1 and D2. For B we have 3 ones and it is for D1, D2, D3. And for C we have 3 ones, that is for D0, D1, D3. And at last for D we have 3 ones, that is for D0, D2 and D3. Now we will discuss types of ROM. So our first type of ROM is mask ROM. Its content and their location is taken by manufacturer from the customer in tabular form. So corresponding mask for the part to produce the desired output. This is very costly as the vendor charges a special fee from customer for making particular ROM. So the uses of mask ROM, it is used in network operating system, server operating system, sorting of font for laser printer and sound data in electronic musical system. Now second type of ROM is PROM, that stands for programmable read only memory. So it is first prepared as blank memory Then it is programmed to store the information. The difference between PROM and mass ROM is that PROM is manufactured as blank memory and programmed after manufacturing, whereas a mass ROM is programmed during manufacturing process. In PROM, burner is used. The process of programming the PROM is called burning the PROM. Also, the data stored in it cannot be modified, so it is called one-time programmable device. So we can use PROM for one time only. The uses of PROM is like that in cell phones, in video games, in console, in RFID tags, in medical devices and any electronics devices. Now moving to third type of ROM, that is EPROM, erasable programming ROM. It's overcome the disadvantage of PROM that once programmed and fixed pattern is permanent and cannot be altered. As we have earlier discussed that PROM is only used one time, but EPROM can be used multiple times. So how it is possible? If a bit pattern has been established, the PROM become unusable. If a bit pattern has been changed, this problem was overcome by EPROM. When EPROM is placed under a special ultraviolet light for a length of time, the shortwave radiation makes the EPROM return to its initial state, which then can be programmed accordingly. Again, for erasing the content, PROM program for or PROM burner is used. So the use of EPROM, it is used in Intel 8048 and Freescale 68HC1. So now moving for third type of ROM, that is E2PROM. It stands for electrically erasable ROM. It is similar to EPROM except that it is returned to initial state by application of electrical signal in place of ultraviolet light. Thus, it provides the ease of erasing as this can be done even if the memory is positioned in computer. It erases or writes 1 byte of data at time. So the uses of E2PROM, it used for storing the computer system BIOS. Then the last type of ROM is flash ROM. It is enhanced version of E2PROM. The difference between E2PROM and flash ROM is that in E2PROM, 1 byte of data can be deleted or written at particular time, whereas in flash memory, blocks of data, usually 512 bytes, can be deleted or written at particular time. So flash ROM is much faster than E2PROM. So the uses of flash ROM. Many PCs have their BIOS stored on a flash memory chips called as flash BIOS, and they are also used in modems as well. Now at last we will discuss what are the advantages of ROM. So the advantages of ROM are as follows. First, it is non-volatile in nature. Second, can be accidentally changed. Third, cheaper than RAMs. Fourth, easy to test. Fifth, more reliable than RAMs. As we already discussed, data remains saved when the power is turned off. And at last, static and do not require refreshing. I hope you all like the video. Thank you very much.